Okay, here are the solutions for 6.11 day 2 homework. Some more trig applications. We just have more complicated diagrams. As always, please make sure your homework is done before you're accessing this video. You're to use this as a resource in case you got stuck on a few. Feel free to fast forward to any point for the particular problem that you need to see. For number 1, we have this diagram and we need to solve for x here. Let's start off by calling this little bit down here A, and this thing up here, that whole distance B. So once we find A and once we find B, we can subtract them in order to figure out what x is. So using this small right triangle to find A, we have A is the opposite of 23 and the 50 is adjacent, so that's tangent. Tangent of 23 is A over 50. A is 50, tangent 23. Which is 21.2237. And to find B then, using that big right triangle, B is the opposite side, 50 is adjacent. And the whole angle there is 38. Tangent of 38 is B over 50. So B is 50, tangent 38. Which is 39.0642. 39.0642. And then to find x is going to be B minus A. So I'm going to go back up here to my calculator. I'm going to take this 39.0642 minus this 21. So I'm going to arrow back up and grab it. And we'll get 17.84. That 5 is going to make that round up. 17.841. And there are no units here, so there's x. In this one over here, we have to solve for x and solve for y. I'm going to find x first using that right triangle up here at the top. And from this 14, that's opposite, and the 80 is adjacent. That's a tangent. Tangent 14 is x over 80. So x is 80 tangent 14. 19.946. All right, there's your x. Now, y, to find y, well, we have to recognize this piece here. That is 35 here. So this is 35. So y is just that x plus 35. I'm going to go ahead and do that. This one, 19.946 plus 35, and we get 54.946. There's y, here's x, and there was x on board. All right, looking at this one. 2 office buildings are 51 meters apart, so the distance between them, 51 meters. The height of the taller building is 207 meters. The angle of angle from the top of the taller building to the shorter building is 15 degrees. This should have been angle of depression. Typo in there. And the top of the taller one, angle, this should be depression. Angle of depression from the top of the taller building to the shorter building is 15. And that's how they've labeled it. Find the height of the shorter building to the nearest meter. All right, so Let's see. There's angle of depression, angle of elevation. This one down here, they are congruent. So that's also 15. It's awful tiny in there. I hope you can see it, that that's 15. And if we can find this distance right here, the difference in height between the shorter building and the taller building, then we could take the taller building, 207, and subtract off that, and then that would give us the height of the shorter building. So let's use this triangle right here and figure out what x is. From that 15, that's opposite and adjacent, that's tangent. Tangent of 15 is x over 51. Multiply by 51, 51. Tangent 15 is x. So let me do that. 51 tangent 15 is 13.665. Okay, now that's this distance right here, the amount that's taller than this shorter one. So to find the height of the shorter building, is going to be 207 minus that 13.665, which was our x. So I'm just going to go back here in my calculator, and I'm going to go 207 minus that big long decimal. And I got 193.335. 193.335, but it says find the height of the shorter building to the nearest meter. So nearest whole number would be 193 meters. All right. Next page. An engineer is 980 feet from the base of a fountain at Fountain Hills, Arizona. The angle of elevation to the top of the column of water is 29.7 degrees. The surveyor's angle measuring device is at the same level as the base of the fountain. It's just so you don't have to account if it was raised up or like 10 feet off the ground. Then you'd have to add on 10. Find the height of the column to the nearest 10 feet. All right, so we need to make a right triangle here. Oops, hope I didn't freeze that. Nope. All right, so we ultimately want to know how tall is this column of water. And we've got some guy, some surveyor, standing 980 feet from the base of that fountain, and he has measured that angle of elevation to the top as 29.7 degrees. And we want to know how tall is the water. That. So setting this up, from 29.7 we have opposite and adjacent. That's a tangent. X over 980 feet. (980) times the tangent of 29.7. Uh-oh. 0.7 is 558.982. It wants this to the nearest 10 feet. To the nearest 10, that 58 is going to round to 60. So 560 feet. That's a pretty tall fountain. It's like 56 stories, and roughly 10 feet is one story of a building. So that's a pretty tall fountain. All right, last one here for this page. A firefighter on the ground sees a fire break out through a window near the top of the building. Sees a fire break out near a window near the top of the building. The angle of elevation to the windowsill is 28 degrees. So you see this, the 28 degrees, this one, to the windowsill. The angle of elevation to the top of the building is 42. So all the way up to the top where her colleagues, other firefighters, are on top of the roof. The firefighter is 75 feet from the building. Her eyes are 5 feet above the ground. What roof to windowsill distance can she report to the firefighters on the roof? So she's wanting to radio up to these guys up here and say, oh, the fire is 12 feet below you, it's 15 feet below you, it's 2 feet below you. She wants to tell them this distance. That's what she wants to be able to tell these guys. So let's call that X. Now, got 3 triangles here. Got the big triangle. Got that triangle. That is not a right triangle, so SOHCAHTOA won't work. And then we have this little right triangle down here. What we're going to have to do is to find this piece, that much. And we're going to have to find this distance and then subtract them, and that'll tell us this distance. And actually the 5 feet above the ground, it doesn't come into play on this one. If they ask you how tall is the building, then it would come into play. But if we just want the difference between these two, this and this, then it's not going to come into play. All right, so let's set this up and let's find A. That's the little right triangle. This 42 is for the big triangle. So 28, opposite and adjacent, so that's a tangent. Tangent of 28 is A over 75. 75 tangent 28. Now, I don't need to know specifically what that is. I'm not going to bother typing it up into my calculator. I'm going to go ahead and find B then. For the big right triangle, the angle is 42. And tangent of 42 is opposite B over adjacent 75. And B is 75 tangent 42. Now we want X. So visually looking at our work, X is this big distance, B, minus the shorter distance, A, which is going to be 75 tangent 42 minus 75 tangent 28. Now I'm going to type that in my calculator. 75, oh, I think I have a decimal point there. Let me start over. 75 tangent 42 minus 75 tangent 28 and 27.652. Doesn't tell us how far to round off, so 27.652, and these are feet. And there we go. Hope this helped. If not, please send me an email. Bye.